Hey guys, welcome back to Consistent Code. So today's problem of the day is smallest number on left. So we are given an array A of integers. Suppose we are given an array of length 3 and the array is 1, 6 and 2. So how are we going to give the output? For the first element, there is no element on the left which is smaller than this because it is itself the first element. So we can say the answer for the first element will always be -1. Now for the second element, the element is 6. Now the element which is smaller than 6 on its left side, the nearest element which is smaller than 6 on its left side is definitely 1. So we will mark 1 as the answer for the second element. Now, for the third element, 2, the nearest smallest left element will again be 1. So here also we have marked 1. Now, how to approach this problem? Now, let me show you this visually how you need to think of it and how you need to build your intuition. So let's consider this array for example. So for this array, the answer will be this -1. And for the smallest left element will be 1. Then for 2 it will be again 1. For 5 it will be 2. Then for 3 it will be 2. Then for 6 it will be 3. So how we arrive at this answer? Now if I plot the graph for index at this x-axis and the values at the y-axis, then we are having something like this. So if I start this graph from here, then I need to just figure out the bottommost points. So I can just start from this point, then I move to this point, then to this point, and then to um, and yeah, so the last point we do not need to cover because that's not a concern, because that will obviously be the value will be the left point which we have marked as orange. So now you can see the answers also. For example, for the first one, the answer should be -1 because for first is always -1. For the second it should be 1, that is 1, right? And for the third one it should be the left point to this, which should again be 1. So this is again 1, as you can see. And for this next point it should be this one, which is 2. So you can see that also. For the next one, this should again be the previous value, which is 2. And for the next one it should be this value, which is 3. So you can see from this graph we can plot this up. Now how to arrive at this conclusion? So what we can do, we can what we are doing, we are just starting from here, then we are picking these elements, and as soon as we found an element which is smaller than this, we just drop all these elements back, and we pop the elements from the stack. We are going to use the stack data structure here because we will fill the elements from this place to here. Then we will, if we found an element smaller than this, like we found this one smaller element, then we will pop this element, and we will keep popping the elements from the top of stack until we do not reach an element which is less than or equal to this new element which we found. So once we pop this element, the next element is smaller than the current element, so we will get something a line like this. So this is how we can use the stack data structure to plot the points. So now let's code our solution. So first of all, I would like to create our vector which we are going to return as our answer. And also I want that for the first value, we already know that answer will always be -1. So I want it to be fixed as -1. Now I want a stack data structure. So I'm calling a stack in S. So now what we will do is start iterating from I equals to 0 to I less than 10 and I plus plus. So we are iterating every element of the given array A. And what are we gonna do now? First we will check that if our stack is empty, what we can do, we can simply push this element in our stack. Now why are we pushing this element in our stack? Because if the stack is empty, that means we are at this situation when we are, like here at this point. There is no element in stack, so there is no choice. We just need to put this value in our stack, and the answer of at this place should be -1, right? So we are gonna just push this element, and the answer for this index will become -1, right? And otherwise, if the stack is not empty, then what we can do, we need to, in that case, suppose the stack is not empty, suppose we fill this element. Now at the next place when we are here, what we need to check, we know that we have checked the stack is not empty, so we need to check if the top of the stack, which is this element, is uh, greater than this current element. If this is greater, we will keep popping this element. So we need to pop the top of the stack until we do not reach an element which is less than or equal to this current element. So we can do that. You can say while the stack should not be empty and the top element of stack is greater than the current element. The current element is a of I. What we need to do in that case? We need to pop the element. So we can say s dot pop, right? And as soon we as find an element, now what happens? There could be two cases now. There can be a case when the stack becomes empty. If the stack becomes empty, then what we can do? We can simply repeat this case which we did before. So I will just paste it here. And next thing would be, what if the stack do not get empty? In that case, what we can do? In that, what would have happened in that case? That the stack is not empty, and the second condition is that the stack stop currently is either less than AI or equal to AI, right? So we can say answer of I should be the top of stack. Great. And now I can simply push the current element into my stack, right? So in all the cases, I'm getting my answer of I. And finally, when this for loop ends, we can simply return our answer. So now let's try compiling and running our code. So we are getting the correct output as we need. Now let's consider another case also, where we are having an input for an array of length 6, and the array is 1 by 0, then 3, then 4, and then 5. If I run the loop for run the code for this, then then also we are getting the correct output. So now let's try submitting this code. So we are getting a wrong answer, so let me see. We are getting it. Okay, so here we are popping the element only if it was greater than this, but we want the smaller element on its left side. So even if the element on its left side is equal, then also we are not gonna consider that element. So we need to put an equal sign here, and now let us see if this case will work. Let's copy this input and paste it here and try running this code for this input for this test case where it was failing. So now it's working fine. So now let's try submitting the code again, and let's see if we pass the test case. So we have solved the problem successfully, and I hope you liked the explanation. And if you did so, make sure you hit the like button and subscribe to the channel for more of such content, and I will see you next time with similar content.